Hi everyone, welcome back from spring break. I hope you all had a great, relaxing week, the best that it could have been under these circumstances. So today we are going to discuss triangles, and these tie into the parallel lines cut by a transversal. Because sometimes when we do that, there are triangles that are created. We can use this when trying to solve for different angle measures and things like that. So the first thing we need to take a look at is the angle sum of a triangle. So, angle sum of a triangle. We know that a triangle is a closed figure, that it has three sides to it. It could look something like this, or it could be different. You guys know that. Basically, the deal is that regardless of the triangle, all three of these interior angles, which means these inside angles, so this angle, and this angle all have to add up to create 180 degrees. So the measure of x plus y plus z has to equal 180 degrees. And that's what makes a triangle, which is something we should know. So basically you're going to have problems today where, here's an example. You're going to be given some kind of triangle. Let's say it looks like this, and it's going to say that there's this here, this is x degrees, and this over here is 55 degrees, and it's going to ask you to find the value. So find the value of x. So essentially, we can see it's a three-sided closed figure. We know it needs to be a triangle. So I'm going to take 55 plus x plus, and then you guys, some of you might be thinking this over here is not labeled, but it is because it has that box. And that box represents a 90-degree angle or right triangle. So plus 90 has to equal 180. So now I have an equation here to work on. I'm going to combine like terms. So 55 and 90 makes 145 plus x equals 180. Subtract 145 from both sides. And x should equal here 35 degrees. So there you have it. We have solved for the interior angle. Let's go ahead and do one more example. So here I have example 2. My video skills are pretty awesome. And I have a triangle. So I have a triangle A, B, and C. And the angles are in the ratio 1 to 4 to 5. So what are the measures of the angles? Okay, so if I have a 1 to 4 and a 4 to 5, that is the comparison of all the angles together. I don't know what the measure is of the angles in general. So if I have a triangle, so here's my triangle again, just to sketch it out nice and big. I have an unknown value here. That's a 1 because anything times 1 is itself, so therefore there's no need to have a different coefficient there. Now this is a 1 to 4 ratio. That means that this angle up here is 4 times as big as this angle here. And then I have a 1 to 5 ratio, which means that this angle over here is 5 times as large as this original angle also. So when I take a look at this, I have 4x plus 5x plus x, and all of those combined have to equal 180 degrees. because I have a triangle and all triangles add up to be 180 degrees. So from here, I'm going to go ahead and combine like terms. So 4x and an x makes 5x, 5x and 5x makes 10x, and that has to be equal to 180. I divide by 10, divide by 10, x equals 18. So from there, we can see what the different angle measures are. So if I substitute in here, that would be 18 degrees. This would be 4 times 18. So that makes 72. And then over here, I have 5 times 18 because I substituted 18 for my x, and that makes 90. So those would be my 3 angle measures of this triangle. That is looking at the angle sum theorem. So I guess we should go back here. Angle sum of a triangle, also known as angle sum theorem. And this is for interior angles. Okay. My handwriting's a little messy. I haven't had to write in a while, so my apologies. But there you have it. So there's that. That's the first part of our lesson. Now the next part of our lesson is going to be taking a look at the exterior angle theorem. So let me just flip this page real quick. Again, sorry for my tech abilities here. So this is exterior angle we'll say theorem. And here we go. So I have this triangle here. And let's say that this line extends. Okay, so I have a triangle, but the base also extends. I have A and B and let's say C, but I also have an angle that's created here, and we're going to call that 1. Okay, so this outside angle here would be 1, and the interior angle here is C, the interior angle here is A, the interior angle here is B. So I have 3 interior angles. That would be the angle sum theorem of a triangle. So I know that A, B, and C have to add up to be 180 degrees. Now, I might be asked to find the measure though of angle 1. Angle 1 is an exterior angle, meaning it's outside the triangle, and therefore I need to come up with another reason why I can figure out what this is. So if I take a look at this, I know that the measure of angle A plus the measure of angle B plus the measure of angle C all have to equal 180 degrees. Everyone okay so far? Okay, that's what we just worked on. So now I'm going to take a look, and I am going to look at how angle A and B have to combine with C to make 180. Well, you can also see that angle C, so the measure of angle C plus the measure of angle 1 have to equal 180 degrees. These two have to equal 180 degrees because they're supplementary angles. They're next to each other. When I combine them, they create this straight line. So therefore, we can use substitution to determine that angle 1 has to be equal to, so the measure of angle 1 has to equal the measure of angle A plus the measure of angle B. So again, if you take a look at this, 1 and C are adjacent. They're supplementary. They have to add to be 180 degrees. A, B, and C all have to add to be 180 degrees because of the interior triangle theorem that all triangles add up to be 180 degrees. Therefore, I can substitute the measure of angle 1 to be equal to A and B, because 1 plus C equals 180, or A and B and C equals 180. So that's how we come up with the exterior triangle sum theorem. So we're going to take a look at this. I am losing my train of thought a little bit. I apologize. Let's say I have something that looks like this. I have a line that's going here, and a line that's going here, and a line that's going here. Something like this. And here I have angle 4, angle 1, angle 3, angle 5, angle 6, angle 2. Again, the outside, so outside is equal to exterior. Inside is equal to interior. Okay, so angle 4 here is an exterior angle of this triangle. Okay, its two remote interior angles are 2 and 3. So what does it mean to be a remote interior angle? That means that these two angles have to be equivalent to this angle over here. They have to be equal to. Sorry, now I have Google Hangouts going off. It's like being in class. I'm being distracted. Okay. So again, taking a look at this, I know that 4 plus 1 has to equal 180 degrees. I know that 1, 2, and 3 have to equal 180 degrees. Therefore, 4 and 2 and 3 have to be the same. So the measure of angle 4 has to equal the measure of angle 2 plus the measure of angle 3. So the exterior angle has to equal the opposite interior angles. And that is the exterior angle theorem. So let's go ahead and take a look at one other problem. Let me, I guess, flip back this way. Okay, so this says that the measure of angle 4 is going to equal 135 degrees. Find, that is not how you spell find. Oh my goodness. Find the measure of angle 2. So I have something that's going to look like this. And, well, that doesn't look realistic. Let's try this again. Okay, that looks a little bit better. This is 2, this is 1, this is 4, this is 5 out here. So this is asking me to find the measure of angle 2. So I know that the measure of angle 4 here is 135 degrees. That's a given. That's given to me. So what I'm going to do here is I'm going to take a look at this. This is an exterior angle. I know that the opposite interior angles have to equal this exterior angle. So therefore, I know that the measure of angle 4 has to equal the measure of angle 2 plus that 90-degree angle. So I'm just going to put 90. So with that being said, the measure of angle 4 is 135, and that has to equal the measure of angle 2 plus 90. I subtract 90 from both sides, and I have the measure of angle 2 is equal to 45 degrees. Another thing I just want to point out though is that we could have used a different method where I could have looked here and realized that these are supplementary angles. So if this is 135, this one would have to be 45. And if I have a 45-degree angle and a 90-degree angle, then this one would also have to be 45. So you could use either one of those, but this is how to use the exterior angle theorem. I hope this helps. If you have any questions, shoot me an email or send me something on Google Hangouts. This will be what we're working on this week. Miss you all. Hope you're all doing well, and I look forward to talking to you soon. Bye.